Hi everyone. So this is the another AMC 12 problem from 2023. So it was number 15. So this is actually one of the questions I really enjoy like trying, because this is kind of a really clever way to ask the question. So the question says Hussein is walking for exercise by zigzagging. So he starts from the corner A, going this direction with this angle measure. And then after that, so just turning this way, having the same angle measure within the line DC. And it will continue in this a few times, which we don't really know how many times this will happen, even though the picture shows on like four pieces, like 1, 2, 3, 4. So, and then at the end, so he's gonna end up getting some point on the side BC. Okay, so what we want to know, what angle measure we should have so he can actually produce a length of 120 meters. Okay, so but we are given that this is like 30 meters on this side, and this side is 100. Okay, so what we need is the angle measure, so we can get the 120 in total for the distance he's gonna take, right? Like if you take the AP and then take a like PQ and continue like this. But again, we have a 4 right here, so the sum of these has to add up to 120, and we just need to know the angle measure for this. And it could be 5, maybe 6, maybe 2, I don't know. So that's the problem wasn't really telling us. So which is why we are gonna just see what we are gonna get. Okay. So to do so, we are gonna find the distance between these two. I mean, some of these distance to be 100. So like including the this one, like maybe 4 or 5 or maybe 3 of those segments, add up to 120. So which means we have to relate this number somehow, the one of these numbers or both of these numbers. So like to do so, I just need some sort of right triangle. So if I drop the altitude from the each like angles, so let's say we drop this altitude, right? And then if I drop the altitude from P as well, and then drop the altitude from this as well. So why this is important? Because if you do like write some trig ratios, like this is gonna be a 30, this is 30, this is 30. So this number doesn't really change, and then you don't know how many times you're gonna take turns like zigzag those, which is why it doesn't look like 30 will be useful. But maybe the 100 might be useful. So if I take let's say this is gonna be x1, maybe this is whatever, and let's say this is x2. Okay, so if you look at this distance, I can write this in terms of this angle and this AP by using cosine. And same idea, I can take maybe this angle and write the cosine of this angle to write the x1 to q, which is the same as this one, divide by this. So let's try it. So maybe that is kind of promising. So if I take the like cosine data, you should get like this distance a x1 over ap. Okay, so and then let's write the cosine of like this data is actually same as this data, and and then this is gonna be same as this one. Okay, so those are all equal because they are alternate interior angles, right? And if I want to write the cosine of this guy, so why do I need to care about the cosine? Because that will give me x coordinates of this piece. So I mean, this leg of this right triangle, which is, I'm going to try to add those together. So if I write the cosine data of this triangle, so that should be x1q over pq. Okay, so I hope you see something going on. If I take the cosine of this data, so cosine data would be qx2 over QR. So you can continue doing this, but we don't know how many of these we are gonna actually have. So which is why I'm gonna just say it will continue. So now let's write these in a different way. So to make it a bit nicer looking. So we wanna know, like, AX1, X1Q, QX2, some of these numbers should be 100. So which is why I'm gonna write those separately itself. Okay, so AX1 is equal to, maybe I should write here. So first, so that means the AX1 is equal to cosine theta times AP. And the same idea right here. So the X1Q is equal to cosine theta PQ. And then for this guy, it's going to be QX2 equals this time this, which will be like that. All of them has the cosine theta as the one of the product. So if I add the left side of those equations, you will get AX1 plus X1Q plus QX2. And it will continue until some number of terms, okay? And then this is equal to sum of the right side, which has all cosine theta. So cosine theta, in parentheses, you can add those together. So the AP plus PQ plus QR, and it will continue some number of terms, okay? Okay, let's see if this is going to be useful because, the sum of these guys is basically the X, like X side or our side, the horizontal distance of those each right triangle. So AX1, X1Q, like this one, QX2, and it will continue that way. So all of them is actually add up to 100. So which is why we can just say this is 100. And then equals cosine theta times AP, PQ, QR, SR. Okay, if you have more or less, the sum of these guys is gonna be 120. So that should be 120. And if you divide by 120, so you will get cosine theta. Cancel that is zeros, and then that will be 10 over 12, which is 5 over 6. So, there's no choice like that since we are looking for the angle measure. So if you take the angle measure of this one, so you just take the inverse of this one. So that would be the cosine inverse of 5, 6, right? Or we can just say this is going to be our cosine 5 over 6. So that is the choice A. So I hope you enjoy this question because it is really clever way of asking questions. So, and then it does tell you have no idea about the number of terms, which is why it's kind of complicated looking. When you start like diving a bit, and I guess it's not too challenging. So that was the answer. So I'll see you in the next video.